Hi there. Thanks for watching. Today we're going to talk about some square roots and how we simplify square roots. So first thing you're going to do is get out your toolkits, please, and you're going to get some definitions down. So first of all, just a quick review. This here says 4 squared. Or you could say 4 to the second power if you wanted to. And it means 4 times 4, which simplifies to 16. So, definition, a perfect square is a product with two identical factors. So we're going to list the perfect squares from 1 to 200. And here's what I mean by that. So 1 times 1 is 1. So 1 is a perfect square. 2 times 2 is 4. So 4 is a perfect square. So 3 times 3 is 9. So 9 is a perfect square. So if you want to, you could kind of pause this and list some more of these on your own. Or if not, you can just watch and follow along and copy these as we go. So this 1 is 1 times 1. 2 times 2 is 4. 3 times 3 is 9. So I was on 4 times 4. X, which is close to 200. And then if I were to do 15 times 15, or in other words, 15 squared, I would get 225, which is above 200. So you don't have to write it down in your list. But just so you know, now we have all of the perfect squares between 1 to 200, and then you have one more there for bonus points. All right. So let's go over, again, another definition on your toolkit. So when we talk about radicals, they're going to consist of what we call a radicand. The radicand is whatever's under the square root. And then the square root symbol or the radical symbol it's kind of like a V with that long tail over on the right. So the radicand's the thing under the square root. So let's look at how to simplify square roots. So for example, the square root of 36 is 6. And the reason is because 6 times 6 is 36. So when we have a radicand, we're looking for a perfect square, one of the numbers on this list that we made. So what times what gives you 36? So the square root of 36 is 6. So if we were to try a couple more examples, and these are going to be on your, we're going to go to your notes as well in just a second, but these can still go in your toolkit. So the square root of 9, think to yourself, what times what is 9? So what times itself? So 9 is 3 times 3. So therefore the square root of 9 is just 3. So now I have the negative square root of 81. So 81, there's a bunch of different stuff. When I multiply it together, it can give me 81. But if I think of the perfect square, 81 is 9 times 9. So the negative square root of 81 is negative 9. And this symbol here, we talked about this before, but this means plus or minus. So literally there's like two different numbers, the positive and the negative case. So 144 is 12 times 12. So this would simplify into plus or minus 12. All right, so that's it for your toolkit definitions. Let's go to your notes. So here's a bunch of square roots. I'm just going to give you a little bit of time. You can pause the video and simplify each of these And then when you're finished, you can hit unpause and check your answers. All right, so we're going to quickly go, I'm just going to quickly write down some of these answers for you. And remember, we're looking for what times what gives you that number under the square root of that radicand. And so these are all what we call perfect squares. All right, so moving on, sometimes you'll have square roots and then you'll have a fraction under that square root. So just like perfect square integers, you can apply the square root to the numerator and denominator. So watch what I mean. So the negative square root of 1/4, you can really think of this as like the negative and then the square root of 1 over the square root of 4. And what's the square root of 1? Well, 1 times 1 is 1, so it's just 1. And then the square root of 4, 2 times 2 is 4, so just 2. So this simplifies to just negative 1/2. So I'll do number 2 with you as well, slowly. The square root of 81 over 121. So I can simplify this or rewrite it as the square root of 81 and the square root of 121. And the square root of 81 is 9, and the square root of 121 is 11. So that's going to simplify to 9 over 11. So again, pause the video and go through some of these, simplify these, and then when you unpause, you can check your answers. All right, let's go through and just check some of these answers. And I notice in number 5 here, I get 7 over 14 when I take the square root. And I always want to simplify that fraction if I can. So I can simplify that a little further. All right. So there we go. Now you can check all of those answers. All right, next thing we're going to do is we're going to approximate each square root to the nearest integer. So what that means is we're going to figure out, like for the example, the square root of 50. 50 is not a perfect square. There aren't two numbers that I can multiply exactly the same and get 50. But what is 50 close to? What perfect square is 50 close to? So I'm going to use this. It's called the approximation symbol. This is an equal sign. This is an approximation symbol, which means it's like approximately or close to. So the square root of 50, is pretty close to 49. And I know that 49 is a perfect square. So this is going to be close to 7. And I know that actually the square root of 50 is going to be a little bit bigger than 7 because 50 is a little bit bigger than 49. So number 2, the square root of 116. So again, 116 is not a perfect square. So if I go, and you can even refer back to your perfect square list that we made in the toolkit, 116 is pretty close to 121. A little bit less, right? So this is going to be approximately close to 11. And square root of 116 is going to be a little bit less than 11 because 116 is less than 121. So you can pause the video here and again, try some of these on your own. And then when you finish, unpause and we'll go over them. All right, so let's go over some of these. So negative root 35 is pretty close to root 36. So this one's a little tricky because 90 is pretty close to 81, which is a perfect square, but it's also close to 100. It's almost smack dab in the middle, but it's 9 away from 81 and 10 away from 100. So I'm going to go with this 81. Although, to be honest, it's really like kind of, like I said, halfway. So this will be close to the square root of negative 9. So the square root negative square root of 200 is close to negative root 196. So it'll be close to negative 14. And then this is really close to square root of 81, or in other words, 9. All right, so this is really useful to kind of estimate, like, what are these square roots close to? But here's the thing, and you can check if you want to on your calculator, but if you were to type in, let me just start with the square root of 50. If you were to type in the square root of 50 to your calculator, so take a second, type that in, you're going to get a decimal. And when I look at my calculator, I get 7.071067 ... So I'm just going to round this to a lot of decimal places. But remember, when we classified numbers, we said that this is what's called an irrational number. It doesn't end and it doesn't repeat. So when I round this, like typically, if I were to say what's the square root of 50, you're going to write down like 7.07 maybe. You're only going to round it to 2 decimal places, but it's not really 7.07. It's approximately that. And so we want to get a better way of kind of simplifying these square roots and not having to approximate. So I'm going to show you how to do that. Finding the exact value. So in other words, we're not approximating. So finding the exact value of a square root. So this is what we do if we get a square root that isn't a perfect square, and you're asked to simplify it. So look at these 2 stars here. If the radicand is prime, so remember, a prime number can only be divided by 1 in itself. So for example, square root of 7, right? 7's prime because the only thing that goes into 7 is 1 and 7. So if the radicand is prime, we can't simplify the square root. Done. There's nothing you can do. If the radicand's not prime, so for example, number 1 here, square root of 50, then you're going to create a prime factor tree, so that's step 1, and you're going to take all the matching pairs out of the square root, so that's step 2. All right, so let's do a couple examples together. So the square root of 50, again, we said it's not prime, so we're going to create a prime factor tree. So you can think, what times what goes into 50? Well, maybe I say 5 and 10. Maybe you say 2 and 25. We're going to come back to 2 and 25 in just a second, but just let's go with 5 and 10. So a prime factor tree, you keep going and factoring until you get all prime factors. So 5 can't be factored anymore, just other than 5 and 1. So I'm going to underline it, indicating that, that's the end of that branch of that tree. But 10 could be 2 and 5. 2 can't be factored anymore other than 1 in itself, and 5 can't be factored either. So in other words, what I'm telling you is the square root of 50 can really be rewritten as 2 times 5 times 5, right? And check on your calculator. Type in 2 times 5 times 5. You'll see you'll get 50. Now, remember, under the square roots, we're looking for like repeat factors. We're looking for perfect squares. Well, this is really 2 times 25, and we just learned that the square root of 25 is 5. No more square roots. So I can simplify this right here. So this is kind of like the square root of 2 times 5. And remember, 2's prime, so I can't simplify that anymore. Now here's the thing. We write the 5 out in front of the square root. We write the plain old number in front of the square root. So this is going to simplify to 5 root 2. So root 50 simplifies to 5 root 2 because I had this perfect square as a part of the 50. That's my answer, 5 root 2. Now let me show you real fast. If you, from the beginning, were like, oh, root 50, that's 25 and 2. Let's see how this would work. So 2's prime, I would underline it. 25 is 5 times 5. Underline both of those. Look at my factors, 5, 5, and 2. So I would still get the same answer. It doesn't matter which way you factor, okay? So number 2, let's go through this one. I need to think about the number 63. It's not prime, so I can create a prime factor tree. So 63 is going to be, I'll say 9 times 7. 7's prime, so I underline it. 9 is 3 times 3. And there's my prime factor tree. So 63 can be written as 3 times 3 times 7. And use your calculator. Type in 3 times 3 times 7. You'll see that you'll get 63. So I'm just kind of rewriting the number 63. And now I notice that I have these 3's here. Well, 3 times 3 is 9. So this is really like square root of 9 times 7. And then the square root of 9 simplifies to 3. I can't take the square root of 7 because it's not a perfect square. So my final answer, 3 root 7. All right, let's do a couple more together. So number 3, the square root of 96. All right, 96, I don't even know off the top of my head what goes into it, but every time I know it's not prime because every time I see an even number, I know 2's automatically going to go into it. So I'm going to make 96 into 2 times 48. So I just used my calculator and I did 96 divided by 2. 2's prime, I'm going to underline it. Okay, now 48 is a little bit more manageable for me. Like I know that 4 goes into 48. So, excuse me, hold on. So 48 is going to be 4 times 12, right? 4 is 2 times 2. These again are prime. 12 I can make into 6 times 2, and 6 is 3 and 2. All right, so there's all my prime factors. I actually have a lot of them. So square root of 96, if I count, I have 1, 2, 3, 4, 5, 2. So 1, 2, 3, 4, 5. And then I have a 3. And again, remember, I'm looking for pairs because I'm looking for perfect squares. So 2 times 2 is 4, and then another pair of, so this become a 4, and then this pair of 2's also becomes a 4. Now this 2 here and this 3 don't have anything to pair up with, so I'm just going to rewrite them. And now under the square root, when I have a perfect square, I can take the square root of that perfect square. So the square root of 4 is 2. Now I have another 4 under the square root. That's another 2. But then these 2 here, they have to stay under the square root because they aren't perfect squares. I can't take the square root of 2. I can't take the square root of 3. So now I've taken the square root of the perfect squares, but now I have like a bunch of multiplications left. When you take multiple things out of the square root, like you can see here, you're going to multiply those 2 2's together. So 2 times 2 is 4. And then this 2 times 3 is 6. So my final answer is going to be 4 root 6. Might be a little confusing, but we're going to do some more example problems together. Don't worry. All right, let's do number 4. So 216. Again, I don't know what goes into 216 off the top of my head, but I know it's an even number. If it's even, I just used my calculator and I did 216 divided by 2, and I got 108. So I know that 2 times 108 gives me 216. And I might not even know what goes into 108, but again, it's even. So I'm going to use my calculator to divide by 2 again. So this is 2 and 54. And again, use your calculator again. Divide by 2 again if you want to. So this could be 2 and 27. And then 27 is no longer even, but hopefully you realize that 27 is 3 and 9. And then this is 3 and 3. All right, so 216 again has a lot of factors. So I have 3 2's and 3 3's, it looks like, right? So remember, we're looking for numbers that pair up under the square root because we want those perfect squares. So I'm going to have like a leftover 2 and a leftover 3. So when I pair up these 2's, I get a 4. And then I just bring this 2 down. And then when I pair up these 3's, 3 times 3 is 9. And then I just have that leftover 3. Now that I have perfect squares under the square root, I can take the square root of 4. The square root of 4 is 2, and the square root of 9 is 3. So I'm going to take this out in front of the square root because the 9 is a perfect square. And then the 2 and the 3, like this 2 here and this 3, are going to stay under that square root because I can't take the square root of them. They're not perfect squares. And then just like we did previously, we're going to multiply. 2 times 3 is 6. 2 times 3 again under the square root is 6. So my final answer is 6 root 6. All right, hopefully these are getting a little bit easier, making a little more sense. If not, we're going to do a couple more. All right, square root of 98. So again, I don't know what goes into 98, but I know it's even, so I use my calculator and I divide by 2. So it's 2 and 49. And then I go, 49, I know is 7 and 7. So this is 2 times 7, right? Now 7 and 7 can pair up, so it's really 2 times 49. And now I can take the square root of 49. The square root of 49 is 7. And then I can't take the square root of 2, that stays underneath. And remember, notice that I put the 7 out in front of the square root. So 7 root 2. All right, number 6, square root of 18. So square root of 18 could be 9 and 2. This could be 3 and 3. Or you could have broken this up into 6 and 3 originally, but then, let's see. Look, if I do 6 and 3, the 6 is still going to turn into a 2 and a 3, and I'll still have 2 3s and a 2. So the 3s give me a 9 when I multiply them together. And then I know that the square root of 9 is 3. And I can't take the square root of 2. So my final answer is 3 root 2. All right, we're going to do 2 more together. So the square root of 54. So again, even if you don't know what goes into 54, you know it's an even number, hopefully by now. And so if you want, you can use your calculator. You can do 54 divided by 2. So I'll say 2 and 27. 27 is 3 and 9. 9 is 3 and 3. And so there's my prime. Remember, that's what's called a prime factor tree. So 54 is going to be 2 times 3 times 3 times 3. So 2 of these 3s are going to pair up. So this is going to be 2 times 9 times 3, because that extra 3 doesn't have anything to pair up with. Neither does that 2. And now I can take the square root of 9. Square root of 9 is 3 times 3, so 3. And then this 2 and this 3 are going to stay under the square root. But now once they stay under, I got to multiply them together. So I get 3 root 6. All right, last one we're going to do together, 40, square root of 40. So I know that's 4 and 10, and 4 is 2 and 2. I'm making my prime factor tree. 10 is going to be 5 and 2, right? So I'm going to rewrite the square root of 40 as, I notice that I have 3 2s and a 5. So what can get paired up? 2 times 2 is 4, and then I have this extra 2 and this extra 5. Now I can take the square root of 4, I get 2, and then the 2 and the 5, I can't take the square root of, right? They don't have any pairs, and they're not perfect squares, so they stay under, and I multiply them. So that final answer there is 2 root 10. So that's it for simplifying square roots. Thank you so much for watching. Hopefully this was helpful.